There is a moment most people have had exactly once and remember for years. A bee lands on you, your hand, your arm, the back of your wrist, and instead of leaving, she stays. She sits there, still, unhurried, antennae moving in small arcs, legs making tiny adjustments on your skin. You don't move. She doesn't move, and you have no idea what is happening. Most people assume the bee is confused or lost or working up to something, but the reality is far more specific, far more deliberate, and far older than that. What she is doing in those seconds has nothing to do with confusion. She is reading you, your temperature, the chemistry rising off your skin, the compounds in your sweat that you don't know you're producing. She is running one of the most sophisticated passive sensory scans in the insect world, and she chose you, your specific body, in that specific moment, because you were, out of every surface in her environment, the most chemically interesting thing available. Welcome back. Subscribe before you leave, because what you are about to understand will reframe every interaction you have ever had with a bee. And it will change the way you think about what a bee sees when she looks at you. Stay with us. The third thing we cover is something that reframes the whole question of why bees land on people at all. Researchers didn't expect to find it, and the last one changes what that moment of stillness actually meant. Number one, what a bee's sensory system is actually doing in the seconds she spends on your skin. Most people assume a bee that lands and stays is disoriented. She flew into you. She hasn't figured out how to leave. And if you hold still long enough, she'll sort herself out. That's the working assumption. It's wrong. Not partially wrong, not missing a nuance, but wrong about what is actually happening in that moment. A bee that lands and remains is not confused. She is reading. The research that established this came from multiple directions simultaneously. Work out of the University of Illinois on chemoreception and foraging insects. Parallel findings from Rothamsted Research in the UK on the sensitivity of bee sensory systems. And what it showed is that bees possess chemoreceptors on both their feet and their antennae capable of detecting chemical compounds at parts per trillion concentration. The moment a bee makes contact with a surface, she begins a passive chemical inventory of everything that surface is currently producing. Sweat composition, skin microbiome signatures, the residue of any topical product applied hours earlier, the stress ketones your body is releasing without your knowledge or consent. This is not a slow process. It happens in the first seconds of contact, and it is continuous for as long as she stays. The antennae you see moving in small arcs are not random. They are sampling the chemical gradient above your skin, measuring concentration and temperature simultaneously, building a profile of you that is more detailed than anything you could produce about yourself with a standard blood panel. Think about what that looks like from the outside. A bee on the back of your hand, still legs making tiny adjustments on your skin, antennae tracing slow arcs in the air above you. It looks like nothing. It looks like she's resting or waiting or simply failing to leave. Or what is actually happening is a dense, rapid chemical interrogation of everything your body is currently broadcasting. The specific ratio of lactic acid to uric acid in your sweat, the lipid composition of your skin surface, the trace signature of whatever you ate 3 hours ago coming through your pores. What this tells you about that moment is this: she didn't land on you by accident, and she didn't stay out of confusion. She stayed because you were, in that instant, the most chemically interesting surface in her immediate environment. You were giving her something to read, and she was reading it. But what she's reading from your skin is only the beginning. What comes next is something most people never consider: what your body looks like to a bee before she even lands. Number two, how a bee sees you, and why you look nothing like what you think you look like to her. Most people assume bees see the world more or less as we do, with perhaps a sharper sensitivity to flowers and movement. The color preferences are different, sure. Everyone knows bees like purple and yellow, but the underlying visual experience seems roughly equivalent. You are a large, warm object. She sees you as a large, warm object. That's more or less the picture. It isn't. The gap between what you see when you look at your own arm and what a bee sees when she approaches it is not a minor difference in color temperature. It is a different world. Research from Lund University and the Australian National University has mapped bee visual perception in detail, and the picture it produces is disorienting. Bees see in the ultraviolet spectrum and are essentially blind to red. Their peak sensitivity sits in wavelengths between roughly 300 and 400 nanometers, well below the range of human vision. What this means in practice is that a bee looking at a human body in afternoon sunlight is seeing something that does not correspond to anything in your experience of looking at yourself. Human skin, depending on tone and sun exposure, reflects UV light in complex patterns that are completely invisible to the human eye, but vivid, structured, and meaningful to a bee. The warm, UV reflective surface of exposed skin on a sunny afternoon can register to a bee's visual system in ways that share properties with certain flower types. Not identical, not a confusion, but overlapping in the signals her visual system was built to follow. Your arm in that afternoon light. You see skin tone, maybe a tan line, the texture of your forearm. A bee approaching from 2 feet away sees a UV bright surface with temperature gradients visible as chemical plumes rising off it. With a luminance pattern her visual system finds salient, with movement properties, breathing, the subtle pulse of blood, that distinguish you from inert objects. You are not a person to her. You are a warm, luminous, chemically active object that has several of the same properties as the things she has spent her entire life investigating. What this tells you about that moment is this: she didn't mistake you for a flower, but you were presenting some of the same signals a flower presents, in some of the same wavelengths, at the right temperature, at the right time of day. A bee doesn't follow intentions, she follows signals, and your body, without your knowledge, was producing them. And then there is the question of why she stayed, because landing is one decision, staying is another. And the thing that makes a bee remain on a human is something researchers didn't expect to find. Number 3, what a bee is deciding in the seconds she spends sitting still on your skin. Most people assume that once a bee has landed, the interesting part is over. She'll leave or she won't. The sitting is just a pause, a brief transition between the decision to land and the decision to go. It isn't a pause. It is the most information-dense part of the entire interaction, and the bee is doing more in those few seconds of apparent stillness than she does during most of her foraging day. Here is what those seconds actually contain. Research from the Menzel Lab in Berlin, supported by work published in the Journal of Experimental Biology, identified and described a behavior called contact chemoreception during surface investigation. When a bee lands on a novel surface, something outside her standard foraging repertoire, something that registered as worth investigating during her approach, she engages a set of sensory structures on her feet called tarsal sensilla. These structures perform simultaneous tactile and chemical sampling. They are feeling the surface and tasting it at the same time, in real time, with a sensitivity that allows her to distinguish between chemical profiles that differ by a few molecules per trillion. What the research showed, and this is the part researchers didn't expect, is that the duration of the landing correlates directly with the complexity and novelty of the chemical profile being read. A simple, familiar surface gets a short visit. A complex, novel surface gets a long one. A human body, it turns out, presents one of the most chemically complex surfaces a bee will encounter outside of a flower. Your sweat alone contains hundreds of compounds in ratios that are specific to you, to your diet, to your stress level, to whether you slept well, to what you put on your skin that morning. She has never read anything quite like it before. She may never read anything quite like it again. The bee on your wrist, not moving. What is happening in that stillness? The tarsal sensilla on her feet working across your skin in movements too small to see, sampling sweat compounds and skin lipids and the trace of sunscreen still present 4 hours after application. Her antennae continuing their arc, measuring the chemical gradient above you, updating her model with each pass. She is not resting. She is working at the upper limit of her sensory capacity, doing something she almost never gets to do, on a surface that is giving her more information per second than most of what she encounters in a full day of foraging. What this tells you about that moment is this: the stillness you interpreted as calm or confusion or a kind of unexpected friendliness was concentration. She was reading something she had never read before, and she was taking her time with it because the complexity of what she'd found was worth the time. Number 4, reframes what you thought you knew about why some people bees land on and stay, and some people they leave. And the answer has nothing to do with what anyone usually tells you. Number 4, why some people bees stay on and some people they leave, and what the difference actually is. Most people believe that surviving a bee interaction without a sting is primarily about behavior. Stay calm, don't swat, move slowly, hold still. The bee will leave on her own. That's the advice, and it's the advice because it's mostly right. But it's right for reasons that almost no one who gives it fully understands. And the part that's missing changes the whole picture. The bee's decision to stay, to leave, or to escalate has much less to do with your movements than you think. It has almost everything to do with your chemistry, specifically with what your body is producing in real time without your control or awareness, in response to what you're feeling. The research that mapped this came out of UC Davis and the USDA Bee Research Laboratory, and it started with alarm pheromone. When a bee stings, she releases a chemical signal, a pheromone blend that recruits other bees to the threat. The primary active compound in that blend is isoamyl acetate. It smells, to humans, remarkably like bananas. And the thing that makes isoamyl acetate effective as an alarm signal is that bees are extraordinarily sensitive to it. They detect it at concentrations far below what humans can perceive, and they respond to it immediately and strongly. Here is where it gets specific. Humans sweat under stress conditions. Real fear, not performed calm, contains compounds that structurally overlap with components of bee alarm pheromone. Certain ketones, certain aldehydes, not identical to isoamyl acetate, but close enough in molecular structure that a bee's chemoreceptors, calibrated over millions of years to detect threat signals, respond to them. A person who is genuinely frightened, holding perfectly still, producing a normal human stress sweat response, is broadcasting a chemical signal that a bee reads as adjacent to alarm. Her stillness is visible. Her chemistry is also visible. And her chemistry may be louder. 2 people, same garden, same distance from the same hive, same posture, same deliberate stillness. One is relaxed, one is frightened and working hard not to show it. The bee that lands on the frightened person is not misreading the situation. She is reading it correctly with the sensory system she has. And the signal she's getting says something is wrong. The stillness doesn't override that. The body doesn't lie to a bee the way it can lie to another person. What this tells you about that moment is this: the advice to stay calm is right. But it's right because calm changes your chemistry, not because it changes your movement profile. A bee isn't watching your body language. She's reading your sweat. And those are very different things to manage. I've saved this one for last because it belongs last. Not because it's the most technical, not because it's the hardest to understand, but because everything before it, the chemoreception, the UV vision, the contact sampling, the alarm chemistry, all of it is prologue to this, to the question of what it actually means when a bee chooses to land on you and stay, when she doesn't leave in 2 seconds, when she sits there on the back of your hand and takes her time. Here is the scale of it. In a full foraging season, a single worker bee will make somewhere between 500 and 1,000 individual trips from the hive. On each trip, she may visit dozens of flowers, land on soil, sample water sources, investigate dozens of surfaces. Over the course of her life, which runs in summer to about 6 weeks, she will make contact with tens of thousands of individual surfaces. The number of times she will land on a human and remain still and unhurried for more than a few seconds is close to 0. It happens. It is not common. In the full sweep of her life, it is almost vanishingly rare. You were one of those surfaces. On one afternoon, on one day, you were the thing she chose to stay on. Research tracking individually marked foraging bees found that human landings lasting more than 5 seconds, the kind where the bee clearly isn't just correcting a flight path, occur almost exclusively when 3 conditions overlap: a human body presenting a novel and complex chemical profile, a bee in an investigative rather than a foraging state, and an environment where no higher priority signal is competing for her attention. All 3 have to line up. Most of the time, they don't. The bee you remember, the one that sat there long enough that you held your breath. She wasn't malfunctioning. She wasn't lost. She had found, in you, something worth the full deployment of her sensory system, something complex enough to hold her attention in a world that is constantly offering her signals to follow. You were, in that moment, more interesting to her than anything else within range. That is not nothing. The weight of her on your skin, less than a paperclip, less than a raindrop, and the complete, focused attention she was bringing to the surface of your hand. She was working. She was, by every measurable standard, doing one of the most cognitively demanding things she does in her life. And she was doing it on you, on your wrist or your arm, or the back of your hand on a Tuesday afternoon while you stood in the garden wondering whether to move. You don't need to do anything differently the next time it happens. You don't need a special posture or a slower breath or a particular way of holding your hand. You just need to know what's happening. The moment isn't random. It isn't an accident of proximity or a mistake she'll correct when she figures out what you are. She knows what you are, or rather, she knows what your chemistry is, and your temperature, and what you look like in UV, and what you've been doing with your body for the last several hours. She has read you more completely in those few seconds than most humans ever will. The people who have held still for a bee and felt something, some version of being seen, of contact that went both ways, weren't imagining it. The bee was perceiving them, actively, specifically, with the full resolution of a sensory system built over tens of millions of years to do exactly this. The exchange was real. Both sides of it were real. They were right to feel it as something. Go back to the beginning, the bee on the skin, still, antennae moving in their slow arcs, legs making those tiny adjustments you can barely feel. You are holding your breath. She is not going anywhere yet. You know now what is happening in every second of that stillness. The tarsal sensilla reading your lipids, the antennae mapping your chemical gradient, the visual system that brought her to you, the UV brightness of your skin in afternoon light, the thermal plume rising off your arm, still processing, still updating. She is building a picture of you that is more detailed than you have of yourself, and she is taking her time because what she found is worth the time. It was not nothing. It was never nothing. It was one of the most sophisticated sensory events in the insect world happening on the back of your hand on an ordinary afternoon while you stood very still and tried not to breathe. Now you know what it was. The next time a bee lands on you and stays, don't move, but pay attention. Notice where she is on your body, how long she stays, and whether her antennae are moving or still. You know now what those movements mean. Watch for it. Tell me in the comments, have you had a bee land on you and just sit there? And how long did she stay? And what did you do? Did you hold still until she left on her own? Or did you move before she was done? If this reframed something for someone you know, someone who's been nervous around bees, or someone who's had that moment and never knew what it meant, send it to them. I read every comment. I'll see you in the next one.